All right, today's exercise is based on program structure using some of these techniques. But to start out, you're just going to revisit what you did last time. The first problem should be really easy. It's just take your simple loading algorithm from last time and make it a function. Okay. We've had you do this kind of thing a few times now. This should be almost automatic. You're going to make a function called load simple, takes as its input the array weights and the capacity of the truck, and returns the output, the weight loaded. Right? So you should be able to just paste your code from problem one in here, problem one last time, and then just wrap it with a function definition. Now, problem two is where we're going to get a little more complicated. All right, so here, now I'm going to go back to the presentation from last time because there was something I skipped, and now it's time to talk about it. All right, so last time we talked about a couple of different algorithms for loading the truck. The simple algorithm, where we just went down the list in order, and then the greedy algorithm, where we always loaded the heaviest remaining weight that would fit on the truck, a way of trying to load more weight on the truck. And we saw that neither of those will give us the optimal solution. So is there some algorithm that will always give us the best possible solution? It'll always load the maximum amount of weight possible. Yes, but it's going to be a really inefficient algorithm. Okay? It's going to be what I'm going to call a brute force algorithm that you probably wouldn't use in practice because it would become impractical if you have a large number of items. But just to show you, and also to use it as an example of program structure, but just to show you it is possible. All right, so how's this going to work? Well, if you think about it, let me back up to one of these earlier slides. Let's go all the way back to the greedy algorithm with sorting. All right. So why did this work better than the simple algorithm? Well, because we sorted the weights, and now when we go through them in order, we'll always be getting the heaviest remaining weight. Well, we could think about it even more. Say, well, what if we just happen to have the 700 here? Let's say that wasn't even there. Let's just move it to the end of the list or something. And then the 300. Let's say this was 300 and that was 400. Well, it would just so happen that we would luck into the optimal solution because it just so happens the 700 and the 300 are the first two items in the list. We're going to hit them first. We get the optimal solution. So the idea is, well, what if we try all possible permutations? We just reorder the weights in all possible ways and apply our simple algorithm to each one and see what gives us the best result. One of those will give us the optimal solution. So that's what we're going to do. All right, so here's how it's going to work. So of course, we start out, we haven't loaded anything yet. So far, the best result we have is nothing. We generate the permutations of the weights. So what I mean by that, there's a built-in function in MATLAB to do that called perms. Let me show you how it works. Let's just generate some weights here. Oh, that's too many. Let me just do 3. All right. Just so you can see it, I'm just going to do a small number of weights. But if I do perms of that, you see what it gives me, a matrix with all possible permutations, okay, all possible orderings of these weights. How many permutations do you get? N factorial. where n is the number of weights. Right, so you can see why this becomes impractical if you have a large number of weights. So up here where n is 10, what's 10 factorial? 3,628,800. All right, so even with only 10 items, you get over 3 million permutations. And this blows up very fast. So this is only feasible with a relatively small number of weights. All right, but having done that, what are we going to do? Well, now we're just going to loop through all the permutations and apply the simple load algorithm to each one and see what gives us the best result. All right, so start at the beginning of the list. So this could be a for loop. Apply your simple algorithm to that first permutation. That's determine how much weight that loaded. And then our new best result is, well, either that weight or the best previous one, whichever is more. Okay, so in other words, each time through the loop, you ask, is the result that I got this time better than my best previous result? If it is, then that's your new best result. All right, and here's an efficient way of doing that in MATLAB with the max function. And then you go to the next permutation. And n factorial, as I said, is just the number of permutations. Okay. All right, so you can do all this, okay, again, in a flow chart, I'm showing everything very explicitly, but you can do all that with a for loop. Okay, you don't actually have to do permutation equals 1, permutation equals permutation plus 1, because that happens automatically with the for loop. And the same here. Okay. You don't have to explicitly say n factorial anywhere. That's just how many permutations you're going to have. So the thing that people get hung up on the most is indexing. And it's not real complicated, but maybe you just haven't had enough practice with it. So let's say, let me go back to MATLAB for a second. All right, so let's call this, I don't know, weight perms or something. Okay, so I've got this matrix, and I want to pass one row at a time. Okay, so you've got to get this indexing right, because here's the set of weights that you want to pass to the function. And then the second time through the loop, you want to pass that row. All right, so one row at a time is going to be weight perms, whatever row it is. So let's say your loop counter is called R, or let's say it's called row, colon. All right, so that's what you're going to pass to the simple load simple function. I think I said to call it load simple. So it's going to look something like this. Right. That little detail seems to be the thing that hangs people up the most. All right, now how is this going to be structured in Grader? Your load simple function goes down at the bottom as a local function. Okay. And then your script to do this flowchart okay, that goes up here. Okay, so your script goes up here. You've got a call to the load simple function okay, on this line. And that function itself, which you did in the previous problem, goes down here. All right, so that's the complicated problem for today. Then the last problem is pretty straightforward. It's just, oh, I forgot, that's right. The next problem is just taking it a little bit farther. But if you get problem 2, I don't think 3 is very difficult. It's just, now that you've made a script with a local function, now what you're going to do is turn that script also into a function just called load truck. Okay, so again, you just copy your code from problem 2 and you just wrap that script into a function definition. So it's to show you how you're going to have, your global function here that can be called by main program. And then down at the bottom, you're going to have the local function. All right. But back to the previous one. To answer a question, somebody asked, this loop is all part of the script. Okay, this flowchart is the script. What's in the local function? Exactly what you did last time. Okay. Okay, so you take your code from problem 1 of the previous exercise, you turn that into a function. So yeah, it'll have a loop inside it as well. All right, so you've got a loop inside the main program that's looping over the different permutations, but then you've also got the usual loop inside the simple load algorithm.